Your AI tool needs to pause and ask for user approval, but you want to keep the implementation simple and direct. We'll see how this FastMCP tool uses ctx.elicit with response type equals none to create a straightforward approval workflow, either executing the action when accepted or raising a value error for any rejection or cancellation. The code demonstrates the minimal pattern for binary approval decisions, while FastMCP automatically handles the empty object schema and async conversation flow behind the scenes.
At MCP, tool. Async def approve action, ctx, context, SDR. Approve an action. Result equals await ctx, elicit, approve this action, response type equals none. If result action equals accept. Return to action. Else. Raise value error, action rejected.
This demonstrates the interactive approval pattern, where tool execution pauses to request explicit user confirmation before proceeding with sensitive operations. The distinctive aspect is transforming what appears as a simple function call into an asynchronous decision point, with the tool's behavior branching based on user acceptance or rejection. Unlike traditional binary confirmation dialogues, this pattern integrates directly into the RPC workflow while maintaining type safety and structured error handling. The implementation works through FastMCP's Elicitation system, which automatically handles schema generation and response validation. When response type equals none is specified, the framework sends an empty object schema to clients and returns a result object where the data field is explicitly none on acceptance. This specific example uses a simple conditional check on result action, treating both decline and cancel cases identically by raising a value error, rather than implementing separate handling for each scenario. This pattern matters because it enforces explicit user consent for critical operations while keeping the implementation simple. The framework's automatic schema management and typed result system reduce boilerplate, allowing developers to focus on the approval logic rather than transport details. For more complex scenarios, FastMCP provides typed result classes and pattern matching support, though this example demonstrates the minimal viable implementation for basic approval workflows. Let's break it down line by line.
At MCP, tool. Async def approve action, ctx, context, SDR. Approve an action.
The @MCP tool decorator exposes this async function as an AI callable tool. The ctx context parameter is mandatory for all FastMCP tools, enabling logging, progress reporting, and user interaction via ctx.elicit. This creates a simple approval workflow. It pauses execution with ctx.elicit, sending an empty object schema, since response type equals none, then either proceeds with do action, on acceptance, or raises value error for any other response. FastMCP automatically wraps the result in typed classes, though this example uses basic conditional checks rather than pattern matching.
Result equals await ctx, elicit, approve this action, response type equals none.
This uses ctx.elicit to create a simple approval checkpoint in an AI callable tool. It sends an empty object schema to the client via response type equals none and awaits user action, returning a result object with either accept or another action type. The code handles only two cases: proceeding with do action, on accept, or raising value error for any non-accept response, including both declines and cancels. For more granular handling, you'd typically use pattern matching on FastMCP's typed result classes like in the official pattern examples.
If result action equals accept.
This implements FastMCP's basic approval workflow by checking the user's response from ctx.elicit. With response type equals none, FastMCP sends an empty object schema where only the action field is populated except decline or cancel, while data remains none. The code handles just two cases. If the action is accept, it proceeds with do action. Otherwise, it raises a value error for both decline and cancel cases. For more granular handling, you'd use FastMCP's typed result classes, accepted elicitation, declined elicitation, canceled elicitation with pattern matching, as shown in the official pattern examples.
Return do action.
This executes the approved action when ctx.elicit returns an accept response. The function uses FastMCP's built-in approval workflow, where response type equals none sends an empty object schema with data equals none automatically handled by the framework. The code implements a simple binary outcome. Proceed with do action on acceptance or raise value error for any rejection, including both decline and cancel cases. For more granular handling, you'd pattern match against FastMCP's typed result classes as shown in the official examples.
Else.
This else branch handles all non-accept cases from ctx.elicit, including both declined and canceled actions. The code uses a simple conditional check on result action rather than explicit pattern matching with FastMCP's typed result classes, accepted elicitation, declined elicitation, canceled elicitation. Raising value error here forces explicit failure for any rejection, while FastMCP's framework automatically manages the empty object schema when response type equals none is specified. This pattern creates a basic human-in-the-loop approval workflow, though more complete implementations might use pattern matching for distinct handling of decline versus cancel cases.
Raise value error. Action rejected.
This raises value error for any non-accept response, treating both declines and cancellations as rejection cases. The simple if-else structure creates a binary approval workflow. Proceed with do action on accept or fail with an explicit error otherwise. FastMCP's framework automatically handles the empty object schema, response type equals none by wrapping it in MCP-compatible metadata, while the ctx.elicit call pauses execution for user input. For more granular handling of decline versus cancel cases, you'd use pattern matching on the typed result classes as shown in FastMCP's official pattern examples. FastMCP approval workflow pattern. The ctx.elicit method transforms synchronous-looking Python into an asynchronous conversation, where response type equals none explicitly requests user approval without data collection. This implementation treats both decline and cancel cases identically by raising a value error, while FastMCP's framework automatically handles the empty object schema required for MCP compatibility. The three possible actions, accept, decline, cancel, exist in the protocol, though this code only distinguishes between acceptance and rejection.
The function that asks for nothing receives everything it needs.